Hello everyone. So in this video I'm going to talk about the conversion of decimal integer and fraction to base R. So first we'll start with decimal integer. I will give you the method to convert it to base R, and then we'll go ahead and do the conversion for the fraction, the decimal fraction to base R. So as I wrote here, we will use the division method in order to convert a decimal integer to base R. So let's consider that we have some number n, which is an. So these are the digits that are inside number r, and 0 to base r. Okay, so I want to go ahead and find any decimal integer, convert any decimal integer to some base r. So for example, we have number 53 base 10, so which means that this is a decimal number, and I want to convert this to base r, which in this case we have r equal to 2. So this means that we are converting that decimal integer into a binary number. So this is how the division method works. So our goal is to find each of these digits inside number n, which is in base r. So basically we have to go ahead and divide 53 by 2. So we're going to divide this number continuously by 2 until we don't have any other numbers that can be divided by 2. So you'll see how this will work. So this will give me 26. So the remainder for this division is equal to 1. So that 1 is my A0. Then again, I will divide 26 by 2. I'm going to get 13. So the remainder is 0. So that will be A1. Again, I will divide by 2. I'm going to get 6. The remainder is 1. And then by 2, I'm going to get 3. Remainder is 0. And then dividing by 2, I'm going to get 1. The remainder here is 1. And don't forget the last 1 here. So I cannot divide this anymore by 2, right? If I divide it by 2, I'm going to get 0, and then there is another remainder here. So we don't have to forget about that last 1. So you have two choices. You can go ahead and don't divide this one anymore by 2. Just go ahead and write it here as the last remainder. Or if you divide it by 2, you're going to get a 0 here, right? So now you don't have to forget about this 0 here. Okay, and since we're dealing with unsigned numbers here, we don't care about the 0 at the left of a number, right? So if I want to write my n here, the number in binary, so I have to start from A6, which is 0, 1, 1, 0, 1, 0, 1, and then I can just neglect the 0 at the left of the number. So this means that 53 in base 10 is equal to 1, 1, 0, 1, 0, 1 in base 2. Okay, so this is how we're using the division method to convert any decimal integer to some base r. And don't forget that I neglect the 0 at the left of this number because we're dealing with unsigned numbers. So if we are including the sign in our numbers, then we cannot neglect any numbers there. All right. So now that we talked about converting the decimal integer, we'll go ahead and see how we can convert a decimal fraction into base r. So the fraction, let's say that we have some number f, which is a decimal fraction. So it is a minus 1, a minus 2, a minus 3, until a minus m base r. Okay, so this time that we have the fraction, we have to go ahead and multiply the number that we have in decimal by that expected base R. All right, so what this means, let me just go ahead and show you an example. So let's say that f, my number, my decimal fraction is 0.625. So this is base 10, and I want to convert it to a binary number, so which means R is equal to 2. Okay, as I said, so here what we have to do, we have to obtain each of these digits, a minus 1, a minus 2 until a minus n. So I have to go ahead and multiply this number by 2. All right, so I'm going to get 1.250. all right, so the integer in this part is giving me one of the digits that I'm looking for. Okay, so my a minus 1 is equal to 1, and then I will take the rest of the fraction up there and again multiply it by 2. So remember that in the decimal integer we were dividing by 2, and now in the decimal fraction we are multiplying by 2. So I'm going to get 0.5. So as I said, the integer will be the digit that I'm looking for, and then I'll take the fraction up there, multiply it by 2, and that will give me 1. So this 1 will be my a minus 3. Okay, and then I have 0 left. So if I multiply 0 by anything, I'm going to get 0, right? So this means that we will terminate here. The process will terminate here. So 0.625 in decimal is equal to 0.101 in binary. Okay, so this process may not always terminate, but if it does not terminate, the result is a repeating fraction. By that I mean, for example, in this particular example we have 0.7 base 10. I want to convert this to binary. Okay, so let's see what if it doesn't terminate, what if it continues, and you'll see that the pattern will be repeating, so you can stop when the patterns start to repeat. So we have 0.7 multiplied by 2, 1.4. As I said, this will be my a minus 1. So 0.4 multiplied by 2 is 0.8. 0 is my a minus 2. Let me just circle this 0 and 1. And then again 0.8 multiplied by 2, 1.6. 0.6 multiplied by 2, 1.2. This one is my a minus 4. And then 0.2 multiplied by 2 is 0.4. So that will be my a minus 5. So you see here, I'm doing 0.4 multiplied by 2, right? This is the same process as starting from here, right? This was 0.4. I was multiplying 0.4 by 2. So again here, I'm multiplying 0.4 by 2. So all of these multiplications will be repeated. All right, so I can terminate here, and I can say that the process is repeating after this number. So I can say 0.7 base 10 will be equal to 0.10110, right? And then again, this process will be repeated. So again, we're going to have 0, 1, 1, 0, 0, 1, 1, 0. So after this first one here, you see that the process is repeating. So I have this one here, and then after that it is repeating. Okay, so this will be this number. Alright, so this is how we convert decimal, integer, and fraction to base R. If you have any questions, you can write them in the comments down below. And thank you.